love the chase and the hunt, and I set the pace when I'm running. I always
Namaste Friends. So today is chapter 83 in the entire Python and chapter 42 in our NumPy. And today is the last chapter on NumPy. So the NumPy, it has been going on for the last 43 days. And I want to thank you for giving me this great opportunity. And you guys can actually pat you on your back because for the last 43 days, we have been busy with the NumPy, which is one of the very important thing in the Python. And we will be getting into SciPy tomorrow. All right. So in this last chapter of NumPy, what we are going to be seeing is set. We have seen a lot of sets, Venn diagrams, A union B, A intersection B, A prime. We have seen lots and lots and lots. Okay. So today we are going to see how to represent the same in a computer language. A set in mathematics is a collection of unique elements. Sets are used for operations involving frequent intersection, union, and difference. Okay, intersection, union, and difference. Now, if you want to create sets in NumPy, we can create NumPy's unique method to find unique elements from any array. Okay, but the array should be only one dimensional. This is not like, we can't keep creating an array like 2-dimensional, 3-dimensional. It's only one dimensional. So, we can find the unique using a one dimensional. Now, if you want to convert, we can convert the following array with repeated elements to a set. Okay, so basically, we are using this unique, right? So we have this, we do this. So we import NumPy as MP. We have an array, a single dimensional array, and then I say, find me the unique in this array. Okay, not to find the set, blah, blah, blah. So the unique will be 1, 2, 3, 4, 5, 6, 7. So instead of this, it is going to be that, okay, which everybody knows. Yeah, exactly the same. Okay, unique is just a distinct. A distinct is just like 1. Okay, so here there are multiple occurrences of 1, so it will be only one time. 1 time 2, 3, 4, 2 times of 5, so only 1 time 5, 6, and 7. So this is the unique, right? If you want to find the union of two arrays, okay, which is union 1D, we take two arrays, okay. You find the unique in one array, and in order to find the union, it is also a single dimensional array only, but you take two variables. All right. So what you would actually do is, you would actually take this, you actually do this here. You would say import NumPy as MP. You will take an array 1, you will take an array 2, you will say a new array, and then you will say unique union one dimensional. We say array 1 and array 2. So we say like, union this. So we will have 1, 2, 3, 4, 5, 6. Okay, because it's actually unions. So when you actually do a union, it removes the duplicates. So the duplicate here is 4, 3. Okay, so it actually removes. So we have 1, 2, 3, 4, 5, 6. All right. So when you actually print this, this is what we are going to get. See here. So the union gives you without the duplicates. Union all gives you with the duplicates. All right. So this is one thing. Now, if you want to find the intersection, you have a union 1D, right? So in this case, what we actually do is we need to find the intersection, which is the difference. Okay, so that will be intersect 1D. So when you want to find the intersect 1D, same arrays and same two variables, and we have intersect 1D, and then we have this thing. So what is it going to give us? It is going to give us 3, 4, because intersection is 3 is common, 4 is common. So this is the intersection. This is the difference. Okay, whatever is common only is the intersection, and that is what is giving this thing. So we say intersect array 1, array 2, and assume unique equals true, and then we actually print this. So this is what it is going to give. All right. So this is what the intersection is. All right. Now, if you see in the intersect 1D, it takes an optional argument, unique, assume unique, which is set to true, can speed up the computation. Okay, it should always be set to true when dealing with with sets. Okay, it should always be, set to true when dealing with the sets. When you want to find the difference, to find only the values in the first set that is not present in the second set, okay, use the set difference 1D method. Okay, which is only in the first set but not in the second set. Understand? First set but not the second set. Use the set different 1D method. I go here and I will do the same as well. Okay, I have a set different 1D method, and let me see what answer is going to give me. So I have this, I have this, and I have this. So set difference, I have set 1, set 2, assume unique equals this, and I actually run this. So it gives me 1. So I'm only trying to find the difference in the first thing. So if you see the first as compared to the second, the only difference I have is 1 and 2, because 3 and 4 is present here. So that is why as compared to the first set, it is 1 and 2, because it is set 1 and 8. All right. Fantastic, fantastic, fantastic. Now, the set one difference method takes an optional argument, assume unique, which we did for the same before as well, and it actually speeds up the computation. And we said you have to do it in the sets in order to speed it up. Okay, so the same thing here. If you want to find the symmetric difference, okay, to find only the values that are not present in both sets, okay, that are not present in the both sets, it's called the symmetric difference. You use set XOR 1D method, set XOR 1D method, and this also takes the assume unique method, which is which is important for your calculation. So what is the symmetric difference? Let's actually see. You have 1 2 3 4, you have 3 4 5 6, and then we have set XOR 1D difference. We have set 1 set 2, we have assume unique. So let's actually see. So we have 1 2 5 6 because these two are common and these two actually go. So this is a symmetric difference. Okay, in 1 and 2 we have which is not present in 2, 5 and 6 which is not present in 1. So this is a symmetric difference, which is 1 2 5 6 put together as 1. Right. All right, friends, these are the different functionalities of sets. I trust you have actually seen my lecture, probably liked it, probably understood the same. If you have any questions, kindly contact me. I'll actually try to explain to the best of my abilities. Like always, I'd like to thank two persons. One is you for giving me a golden time, and the other is my wife Jayashree, following me to follow my passion. Till we see next time, take care, cheers, and a big thank you. We are done with NumPy. So from tomorrow to sci-fi, I'm excited. And I'll tell you how important is sci-fi and the basic concepts that we covered in NumPy. If you want to build the pyramid, the way you would actually go was NumPy first and sci-fi, and that is exactly what we did. All right, thank you.